Welcome back to the AI-MCP Agent Use Case Library. I'm George Snyder, one of the developers of the platform. Today we're going out to an oil field. Here's how this usually works. One system spots the problem. A second is where an engineer diagnoses it. A third is where someone types up the work order. 3 systems and a person carrying the answer between them. The agents you're about to see do all 3 steps themselves. Nobody types a word to them. So what exactly have they been asked to do? This operator runs wells across several pads. Every one of them is on artificial lift, a pump that has to keep working for the well to produce anything at all. On a schedule, our agents check each well and answer one question in plain language. Is this well running normally? Is it due for service? Is it heading for a failure, or has it already failed? Then they price that answer, what the repair costs, and what you lose every day you wait. You don't need to know a thing about oil wells to follow this. And this isn't one agent. It's 3 working in a line, built on a single canvas with no code. The first reads what each well is actually doing and compares it against that well's own declared operating limits. The second takes those findings and works out the condition of the equipment itself. The third turns the diagnosis into a plan. What job, which parts, whose crew, how soon. Each one hands its answer straight to the next. Let's open the middle one, the Equipment Health Specialist. It's a small focused thing with its own instructions, its own tools, and its own knowledge. That's deliberate. One agent told to do all 3 jobs gets vague at all 3. Splitting them means each can be tested and corrected on its own, and you can see exactly which step made which call. And each one can run a different model, so you're not paying for a large one where a small one does the job. Now the part that matters most, how this agent reaches real equipment data. It goes through MCP, the open standard for giving an agent genuine capabilities, and it's connected to 3 separate systems. First, the field controllers, what the well is doing right now. And look at this tool, get operating limits. The agent asks each well what normal means for that well, and it never assumes. Next, the production surveillance side, where the pump's own signature gets read. And third, the maintenance system that holds the work orders, the parts, and the crews. 3 systems that don't talk to each other. Today, a person is the integration between them. Numbers on their own still aren't a diagnosis, and that's what the knowledge base is for. Here's the exact case it exists for. One well has its pump fillage falling, its fluid load falling, its motor current rising, and its cycle count climbing. And every single one of those readings is still inside the alarm limits. A threshold alarm calls that well fine. These documents are what tell the agent that those 4 moving together are one worn pump heading for failure, and the agent names the document it took that from. This is a well site, so let's talk about what these agents are not allowed to do. The 3 in the chain carry a notice on every finding, advisory only, reviewed by a qualified person. But this one, the agent a technician can actually talk to out at the well, carries hard blocks. Change the set point, stop the pump, shut in the well, silence the alarm, and the 2 that matter most, safe to work on, and it is isolated. Ask it any of those and it refuses, and it explains why. Stopping a unit from a controller is not an isolation. So here's the operator's own console, a real page, not a mock-up. 2 pads, 6 wells. The board is holding the last sweep that ran. On this pad, 1 well running normally, 1 due for maintenance, 1 heading for failure, and 1 already failed, each with the readings behind it, the job it needs, and the document that call came from. And notice those work orders sit as pending approval. The agent doesn't approve anything. Now, watch the top of the screen because we've just started a fresh sweep. It's going well by well. Collect the condition, assess the equipment, plan the response, and every one of those steps is a real call out to the agents we just looked at. Their console has the answer. But look where we are now. Those same runs recorded on the platform side in full. Every tool the agent called, the tokens, the cost, the time it took, and the complete response it gave, exactly as it gave it, the well it was about, and the classification it landed on. So the field gets a work queue and the platform keeps the receipt. If you ever have to show somebody what your AI did to a piece of equipment and why it said what it said, that second half is worth every bit as much as the first. So, 3 specialists in a line that nobody chats with, started by the operator's own console, judging every well against that well's declared limits instead of a rule of thumb, explaining itself out of the field's own documents, refusing to touch a thing, and handing back a priced-ranked plan that a person approves. Swap the equipment and swap the rulebook, and that's your operation. Thanks for watching. I'm George Snyder, and I'll see you at the next AI-MCP use case walkthrough.